Today we will be studying about the chapter language of chemistry. So what do we have in this chapter? Well, first of all, when it comes to representing elements with their symbols, you know the symbols of the elements, at least for those whose atomic numbers lie between 1 and 20, because those you had in your syllabus in a previous class, in class 7. So say for atomic number 1, there is this element hydrogen with symbol H. Next, say for atomic number 14, we have silicon whose symbol is Si. So you basically know the symbols. Generally the symbols are one capital letter or a capital letter followed by another small letter. That is the symbol of these elements, and generally when we write the symbol like this, it denotes one atom of that element. That is the denotion. And what about valency? Well, again, valency, you know, it's the combining capacity of an element. Valency is combining capacity of an element. That is valency, the combining capacity of an element. And well, while most of the elements have got a single value of the valency, there are a few of the elements which have variable valencies. So let us start dealing with this one by one. First of all, let us consider this small chart where we will write down the atomic numbers of the elements and their corresponding symbols. So for atomic number 1, it's hydrogen. For 2, it's helium. For 3, it's lithium. For 4, it's beryllium. At 5 and 6, we have boron and carbon. At 7 and 8, we have nitrogen and oxygen. Finally, at 9 and 10, we have at 9 we have fluorine, and for 10 we have neon. And similarly, if you go for the next 10, at 11 we have sodium. Atomic number 12 corresponds to magnesium. Atomic number 13 stands for aluminium. 14 for silicon. 15 for phosphorus. 16 for sulfur. 17 for chlorine. 18 is argon. 19 is potassium, and 20 is calcium. Now that is all about the atomic numbers and their corresponding symbols of the elements. Now we will know another new thing, which is valency. What are the valencies? Well, let us first write down the valency of the element hydrogen, neon and argon. Why? Because their valencies are 0. These are what we know as the noble gases. So noble gases, they do not combine with any other element, so their combining capacity is 0, their valencies are 0. They have completely filled electronic shell configuration, so they can neither donate an electron nor gain an electron. Next, let us look at this pattern. Well, following the 1 0 here, we have lithium, which has got a valency 1. Following neon, sodium has a valency 1. Following argon, potassium has a valency 1. Next, similarly, for beryllium it's 2, for magnesium it's 2, for calcium it's 2. And it will so on follow like this. For boron it will be 3, for carbon 4, for aluminium 3, for silicon 4. But after 4 it comes back again. So 1, 2, 3, 4, next it becomes 3, 2, 1, 0. 1, 2, 3, 4, 3, 2, 1, 0. Now what is left is hydrogen. Well, when you will be in higher classes, you will know that there are a lot of controversies regarding where hydrogen should be placed in the periodic table. It has got a dual nature. Sometimes it behaves like electropositive, sometimes it behaves like electronegative. But for now, the combining capacity or valency of hydrogen is 1. So these are the first 20 elements. as per your syllabus right now, you must know the atomic numbers, the names, the symbols and the valences of the first 20 elements in the periodic table by heart. But these were certain valences which are fixed. But as we said, there are other elements as well where we see conditions of variable valency. What about those? So let us deal into some of them. Some elements which have got variable valency. As per your syllabus, your book, you have the examples of these elements: copper, lead, tin, iron. Copper, iron, lead, tin and mercury. First of all, you need to know their symbols. Copper is Cu, iron is Fe, lead is from the Latin name plumbum, so Pb, tin also from the Latin name stannum, so Sn, and mercury, Latin name hydrogyrrum, so Hg. What are the values of their variable valencies? Well, copper certain times has valency 1, certain times has valency 2. Iron, at times it has valency 2, at times it has valency 3. Lead has got variable valencies of 2 and 4. Tin has variable valencies of the same value 2 and 4, and mercury have variable valencies of 1 and 2. Now how do we name them? When if it's variable valency 1, we simply write like this: copper within bracket Roman numeral 1. For 2, we write copper within bracket Roman numeral 2. As simple as that. Similarly, for iron, it will be for the first one, iron within bracket Roman numeral 2. For the second one, it will be iron within bracket Roman numeral 3. Follow it up with lead. For lead, it will be lead 2 and lead 4. For tin, it will be tin 2 and tin 4. Finally, for mercury, we will have mercury 1 and mercury 2. So that is all about the variable valencies. Next we have this topic of ions. What are the ions? Type of ions? Well, the ions are of two types. You either have cations or you have anions. Cations are the ones which are positive charged, and anions are the ones which are negative charged. So when do we get cations? When do we get positively charged ions? If you have a electron deficit, that is, if you lose one or more electrons, you have an excess of positive charge, that is excess of protons in the nucleus. So number of protons increases the number of electrons, so there is a net positive charge. And if there is a electron excess, in that case the number of electrons is greater than number of protons, so there is a net negative charge. Those we say as anions. Now based on what is the charge, the symbols change. Like if it is sodium, the cation of sodium has a charge 1 plus because it has got only one deficit of electron. But if it's calcium, it is Ca2 plus because it has 2 less electrons than protons. Similarly for anions, if it is chlorine, it is simply Cl minus. But if we look into some other anion, say for example oxygen, it's O2 minus. So this is how the values of the valences, the charges change. And you write down the charges like this. They are always written down as a superscript with this sign, depicting whether it's a plus charge or a minus charge. In your book you should also find that there are a lot of elements, a lot of cations and anions whose charges are mentioned. You need to know these charges as well. Like for the hydrogen ion, sodium ion, potassium ion, that's H plus, Na plus, potassium plus, these are the hydrogen, sodium, potassium ions. All of them have got a charge of +1. Next, in the range of +2, we have the magnesium ion, we have copper ion, copper 2 we have the calcium ion. These are the ones which are having a charge of +2. Similarly, for +3, we have aluminium 3 plus, it has got a charge of +3. Alright, and what about negative charges? For negative charges, again we have ions like hydride ion, chloride ion, bromide ion, iodide ion. All of them have got charges of -1. Then there are certain other ions like oxide ion, O2 minus, sulfide ion, S2 minus, they have charges of -2. And finally, what about charge -3? We have the nitride ion, N3 minus, and the phosphide ion, P3 minus. They have got a charge of -3. But these were all the ions that we discussed now, till now, they were all simple ions. By simple I mean that they were not the combination of one or more elements. There are certain ions as well which are combination of one or more elements. The classic one being the ammonium ion, NH4 plus. It is a monoatomic ion which has got a charge of +1, but it is a combination of one nitrogen with 4 hydrogen atoms. So like this, we have got a few other polyatomic ions as well. I need to know their charges as well. Like the hydroxide ion, OH minus, we have an oxygen atom and a hydrogen atom and a net charge of -1. Next we have the nitrate and the nitrite ion. This is the nitrate, NiTrate, and this is the nitrite, NO2 minus, NiTrite. The nitrate and the nitrite. We have the sulfate and the sulfite as well. Sulfate is SO4 2 minus and sulfite is SO3 2 minus. This is sulfate, this is sulfite. Then we have carbonate and phosphate ions. CO3 2 minus and phosphate is PO4 3 minus. We also have phosphite, which is PO3 3 minus. So these are the charges. This one is the carbonate ion, this is our phosphate ion, and this is the phosphite ion. So all that we have been doing till now, they are pretty much factual. So I shall be stopping here today. From the next class I will be starting about the chemical formula of the compounds. But before that, let me just say that whatever we did till now, the basic thing that you need to do is you need to remember properly what is the name, what is the value of atomic number and the value of valency for the first 20 elements of the periodic table. Then you have to study that which elements have variable valencies and what are their variable valencies. Is it 2 and 3? Is it 2 and 4? Is it 1 and 2? And so on. And finally, you shall deal with these different kinds of cations and anions which are present within your syllabus. And from these cations and anions, you need to study their charges again, like whether it is the ones like hydrogen, sodium and potassium which has charge +1, or whether it falls into the classes of magnesium, calcium, copper having charges +2 and so on. Similarly for the negatively charged ions. And finally you shall have to also study about the various kind of polyatomic ions where there are more than one elements combined in the ion, like the ammonium ion, the carbonate ion, sulfate, nitrate ion and so on.